Everything in episode 3 was about materials getting dangerously brittle in the cold. Part ULT covers the opposite problem, materials that actually get stronger as the temperature drops, and how to take credit for it. Welcome back to ASME Section 8 Division 1 in 5 minutes. Season 2, Episode 8, Part ULT, Low Temperature Vessels. ULT 1 spells out the point directly. These are alternative rules for materials that get increased allowable design stress specifically because of low temperature service. Certain steels and alloys don't just survive cryogenic conditions, they gain strength there, and this part exists so you are not stuck designing to a warm temperature stress value when the material's actually performing better cold. It's the flip side of episode 3's brittle fracture concern. Same extreme cold, completely different material behavior, completely different rulebook. Table ULT 23 covers a specific list: 5, 7, 8, and 3% nickel steels, the classic choice for LNG and cryogenic gas service, type 304 and 316 stainless steels, and 5083 aluminum. These aren't arbitrary choices. Each one has documented, tested strength behavior at cryogenic temperatures that's actually better than its room temperature rating, which is exactly what makes this whole alternative approach possible. Here's the part that trips people up. Even though the vessel operates cryogenically, ULT 27 has you calculate minimum thickness two separate ways. First, using the actual allowable stress at the operating temperature, corresponding to the warmest cryogenic fluid's saturation temperature at MAWP. Second, using the stress value at a fixed 150 degrees Fahrenheit reference point. You take whichever result demands more thickness. That 150 degrees Fahrenheit check exists because the vessel doesn't stay cold forever. During warm-up, upset conditions, or before it's ever filled, it has to still be safe at a warmer temperature too. And don't mistake higher allowable stress for less testing. The nickel steels still require notch ductility testing under UHT 5 and UHT 6 rules from episode 6, tested at the coldest temperature the vessel will actually see, not a warmer stand-in. Even more striking, type 304 and 316 stainless steel, which normally get impact testing exemptions under UHA 51 elsewhere in the code, lose that exemption entirely here. Cryogenic service is demanding enough that the code strips away an exemption that would otherwise apply to these exact same materials in ordinary service. A few service level details worth knowing. The relief valve setting effectively controls the vessel's maximum operating temperature for that specific fluid. Insulation always goes on the outside of the pressure boundary, and any structural attachments or stiffening rings welded directly to these pressure parts have to match or exceed the base material's strength. This isn't a part you improvise around. Every piece of it assumes a very specific, well-characterized cryogenic fluid. Quick recap, Part ULT lets specific materials, nickel steels, 304 and 316 stainless, 5083 aluminum, use higher allowable stress because they get stronger cold. Minimum thickness gets checked both at cryogenic operating temperature and at a 150 degree Fahrenheit reference point, whichever governs. And testing requirements, including exemptions elsewhere in the code, get tightened, not relaxed. That's Season 2, Episode 8. Full material table is linked below on Weld Fab World. Subscribe. Episode none covers mandatory Appendix 47's rewritten designer qualification rules.